Hello everyone, welcome to the next tutorial. In this tutorial, we are going to study in detail about inductor. Okay, so before studying about inductor, we need to learn about Faraday's laws. Okay, Faraday's laws. So what are Faraday's laws? So Faraday's laws explains the various kinds of electrical magnetic phenomena that happens with the conductors. Okay, so number one, Faraday's first law. Okay, Faraday's first law. So Faraday's first law, so this law states that whenever a conductor is placed inside a alternating or you can say varying magnetic field, okay, and EMF is induced in it, and EMF is induced in it. Okay, so if there is a closed path in this particular conductor, then a current will start to flow. Okay, the next one we have is the Faraday's second law. Okay, Faraday's second law. So the magnitude of the electromotive force. So according to Faraday's second law, the magnitude of electromotive force, or you can say EMF, is directly proportional to the rate of change of your flux. Okay, so d phi by dt. So if we remove the constant of proportionality over here, we are getting E is equal to n d by dt of phi. Okay, n stands for the number of turns in a conductor. Okay, so let's say there is an inductor and an alternating supply is connected across it. Okay, so an alternating supply is given to it, and the core of the inductor is your iron core. So the core of the inductor is your iron core. Let's say psi is your total magnetic flux. Okay, so psi will be equal to n times of phi. Okay, so what is n? N is the number of turns of the inductor coil. Okay, so let's say this is your first equation. So according to Faraday's second law, E is equal to n d phi by dt. Okay, d phi by dt. Also, psi is also equal to L into I, where I is the current flowing through this particular inductor. So I is the current that is flowing from this inductor. Okay, so we can say that, so from this particular equation, like it is very clear, like on substituting the value, it means that psi n phi will be equal to L I. Okay, so if we differentiate phi with respect to the time, we are getting n d upon dt of phi will be equal to L d upon dt of your I. Okay, so n d phi by dt is your induced EMF, okay, which will be equal to L d upon dt of I. Okay, so E is equal to L d upon dt of I. Okay, so this is a very important equation, and this is your fifth form of Ohm's law. Okay, fifth form of Ohm's law. So it means that the value of the current that is flowing from the inductor can be given as I will be equal to 1 upon L integration of E dt. Okay, in a given time interval. Okay, so from this expression we can also find the energy that is stored by an inductor. Okay, so we know that P, which is power, is equal to V into I. So the value of the induced EMF is equal to L d by dt of I. So it means that on substituting the value of V, we can get P will be equal to L di by dt into I. Okay, also the total energy, or you can say the work done, is equal to integration of P into dt. Okay, so we can substitute the value of the P power over here, over in this expression. So we can get integration of L I di, okay. So it means that W will be equal to, so L is common over here, 1.2, okay, I square, okay. So the energy, it means that, so energy stored by inductor is given by an expression W is equal to half L I square, okay. So this is also one of the most important expression which you need to remember, okay. So ideally, okay, so ideally an inductor is given by this expression, okay, and the internal resistance of an ideal inductor, so the resistance of an ideal inductor R is your 0 ohms, okay. But practically there exists some kind of internal resistance in your inductor. So this is your internal resistance, this is the value of the inductance L, okay. So this is your practical inductor, okay. So in case of a practical inductor, there exists some kind of internal resistance, okay. So it means that for an ideal inductor, the power dissipation, so the power, or you can say the energy dissipation or the power dissipation for an ideal inductor is 0, okay, 0 watts. The next point we have, inductor always stores energy in form of magnetic field, okay. So it means that, that's why since it stores energy in form of magnetic field, so it is also known as your dynamic element, okay. So it is also known as dynamic element. So these are very important points which you need to remember, okay. So in the next tutorial, we are going to learn about the characteristics of inductors in detail. And that's all for today, guys. I will see you in the next tutorial. Thank you.